Today I'm going to talk about the balance of body functions, and the goal of this video is to explain the meaning of homeostasis and give an example of a typical homeostatic mechanism. So, what is homeostasis? Homeostasis is any relatively stable or constant internal condition of the human body. Some examples would include body temperature, blood pressure, and heart rate. To function properly, your body temperature should be approximately 98.6 degrees Fahrenheit. Your blood pressure should be approximately 120 over 80, and your heart rate should be approximately 68 to 75 beats per minute. Now, how does the body maintain homeostasis? It does this through a feedback loop. And a feedback loop is a specific kind of mechanism used to control the internal conditions of the body. What kind of mechanism? Well, it has to have three parts. It has to have a control center, a sensor, and an effector. To get the basic idea of how it works, I'm going to give an analogy based on the picture you see here. So, say it gets cold outside of the school building, and it makes the temperature drop inside the school building. Now, there's a sensor inside the school building that detects the change in temperature, and in this case, the sensor is a thermometer. The thermometer sends that information about the change in temperature to the control center, which in this case is a thermostat. And the thermostat compares the actual temperature inside the school to the temperature it's supposed to be at, the set value that's on the thermostat. Okay, the thermostat then activates the effector, which in this case is the furnace. And we call it the effector because it has an effect on the internal conditions, which in this case is the temperature inside the school building. The sensor continuously feeds information back to the control center. So when the temperature inside the school is restored to the set value, the thermostat will turn off the furnace. This is an example of a feedback loop. Now, the body uses a similar feedback loop to restore our internal body temperature. Nerve endings act as the temperature sensors that feed information to a control center in the brain. Part of the brain compares the actual body temperature to the normal body temperature. In response to a chill, the brain sends nerve signals to muscles that shiver. And the shivering produces heat, which is going to increase our body temperature to try to get it back to the set value, approximately 98.6. Now, there are two types of feedback loops. The first is a negative feedback loop. A negative feedback loop opposes a change to the set value. And an example would be the one I just gave about how we restore our internal body temperature in response to change. Most of the feedback loops in the human body are negative feedback loops. The second type of feedback loop is a positive feedback loop. A positive feedback loop increases or amplifies the change to a set value until something stops the process. Though rare, there are positive feedback loops in the human body, and a great example would be when a baby is born. As the baby is pushed from the uterus into the vagina, stretch receptors detect the movement of the baby. That information is fed back to the brain, triggering the release of a hormone called oxytocin. And oxytocin stimulates stronger contractions. The stronger contractions push the baby farther along the birth canal, thereby increasing the stretching, and that stimulates the release of even more oxytocin. And the contractions just keep getting stronger and stronger until the baby is pushed out of the body and the positive feedback loop is broken. So, to sum up, we've explained the meaning of homeostasis, and we've explained how the body can maintain homeostasis through a feedback loop.